Supposing you are the one to answer this, how would you do that? One, you have to define simple harmonic motion. So can I have any one of you to help us define simple harmonic motion? Any one of you to help us do that? You are free to respond. Oh, let's not waste time. We must do a lot within the time. So quick one. How would you define? Okay, Erifa, how will you define simple harmonic motion?
The simple harmonic motion is a repeated to and fro motion about a fixed point whose acceleration is directly proportional to the displacement and occurs in the opposite direction.
That's it. So the repeated to and fro motion of a body whose acceleration, the repeated to and fro or up and down motion of a body whose displacement is directly proportional to the acceleration, but oppositely directed and always directed to the mean point. That is simple harmonic motion. Now B, sketch a displacement time graph for a simple pendulum undergoing a large angular displacement for 2 complete cycles. When we were going through the practicals under this, I said that one precaution, I'll even give you two precautions in simple pendulum and then loaded spring experiments are that one, you must give the pendulum or the simple pendulum small angular displacement, small angular displacement. So when the angular displacement given to the system, the simple pendulum is large. When theta is large, it introduces huge error. So theta must be very small. In fact, very small. This is one key precaution under oscillatory experiment. The other precaution is that put off all fans and even close windows so that we do not have air resistance from external source. So you must put off all fans and close windows. The idea behind this is that so that we do not have air resistance, because external factors must not affect the experiment. If external factors such as air resistance and friction hit the thread or the string interacting or scratching the rotor stand of the pendulum bulb, you will not have fixed amplitude. If the amplitude is not fixed, it will affect the period of oscillation. So these are two key precautions in oscillatory experiment. Okay, so if the angular displacement is small, what happens? What happens to the displacement time graph? This is what will happen. For 2 cycles, if the angular displacement is small, this is how the displacement time graph will look like. So the oscillation will be free oscillation, where the amplitude of oscillation is the same. I must revise my wave. The amplitude is changing. So this is one cycle. Another cycle must have the same amplitude as the first one. This is what happens when the angular displacement is small. The body would oscillate freely. In free oscillation, amplitude of oscillation is the same. If we are to even draw it for 3 cycles, each cycle would give us the same amplitude throughout. This is free oscillation, meaning that the system will not lose energy, okay, to air. And so the amplitude will be maintained throughout. If if theta is very small, and this answers the question. Glenn, please mute yourself for us, okay? If theta is very small, then this displacement time graph, this is how it will look like. For 2 cycles, because the system will lose energy to the surrounding air, the amplitude will be dropping with time. One cycle and then the second cycle, you realize that the amplitude will be dropping. Okay, and this is termed as damped oscillation. And in damped oscillation, the oscillation body loses energy to the surrounding air, or loses energy through friction. And so the amplitude will be dropping. If we are to go another cycle, it will be giving us this. So this is what will happen when you give a simple pendulum large angular displacement. Class, is that okay?
Yes, please.
All right. Then the next question.
Mr. India.
Hello, Leslie.
Please, can you go over the damped oscillation?
So in damped oscillation, okay, what damped oscillation basically means is that oscillation of a body whose amplitude changes with time. Okay, so instead of having same amplitude throughout, irrespective of the number of oscillations, this time you realize that the amplitude will be dropping. Look at the first amplitude, very light. Second one is dropping. This is damped oscillation. And what brings about damped oscillation? Damped oscillation occurs when the oscillating body loses energy to the surrounding air, or loses energy due to friction. Okay, and that is what happens when you are doing simple pendulum experiment and you displace it at a large angle. The system will be losing energy to the surrounding air molecules, and so it will lose energy. Okay, so that is basically about damped oscillation. Energy can also be lost due to friction between the thread pendulum string, hitting the rotor stand in every oscillation. You will lose energy due to friction or due to air resistance. And that's why in this experiment, we must always give a small angular displacement and also off all fans and close windows to do that. Leslie, are you okay?
Yes, please.
Okay. Then the next question. A body of mass 100 grams performs simple harmonic motion with an amplitude of 4 centimeters. So the mass of the body is 100 grams. Amplitude is 4.0 centimeter. If it completes 20 oscillations in 15 seconds, so number of oscillations 20 in a time given as 15.0 seconds. Calculate the minimum velocity, I. Then II, total mechanical energy at the equilibrium position. And we are to take power squared to be equal to 10. So we are first calculating the minimum velocity. So please, class, work on the minimum velocity whilst I take attendance and then upload it on the page, okay? Work on the minimum velocity.
Recording in progress.
All right, so what is your value of the minimum velocity? Anybody? The minimum velocity. The minimum velocity of an oscillating body or a body executing simple harmonic motion is always 0. This is always 0. This is because the minimum velocity occurs at the extremes. Okay, and at the extremes, the displacement is equal to the amplitude. So if the displacement is equal to the amplitude, then the amplitude and displacement, we are given the amplitude to be 4, and the displacement would also be 4 at that point. And so when you use V is equal to omega times square root of A squared minus Y squared. Because Y is equal to A, it will be equal to, 0. So the minimum velocity of a body executing simple harmonic motion is always 0. Class, are we okay?
Yes, yes.
All right. The total mechanical,
Mr. please. Under which circumstance will we use the V is equal to amplitude times omega cos omega t?
that is
Can it apply in this situation?
that is when you are given time to calculate, okay, for the velocity. So this the equation V is equal to A omega cos omega t. This is velocity in terms of time, and this is velocity in terms of displacement. Are you okay?
Yes, please.
All right, so we have to determine the total mechanical energy at the equilibrium position. And look at this. For a simple pendulum, at every 2 points, energy is said to be conserved. So this is the fixed point. When it moves to one extreme and the other extreme, the total energy of the oscillating body at the extreme must be equal to the total energy of the oscillating body at the mean point. When you pick every 2 points, okay, the total energy there must be the same. So at the extreme, V is 0, velocity is 0, meaning kinetic energy is always also 0. KE is also 0. But potential energy is maximum here at the extreme. At the midpoint, potential energy is 0, but kinetic energy is equal to maximum. Okay, and because a drop in one form of energy is a gain to the other, total PE at the extreme must be equal to the total KE at the mean point. All right. So that's just it. So if we are looking for the total energy, okay, the total energy, mechanical energy at the mean point. Don't forget, mechanical energy is KE plus PE. And at the mean point, the total mechanical energy will be equal to the maximum kinetic energy. This is because at the mean point, PE is 0. So the mechanical energy will simply be equal to the total kinetic energy. Mechanical energy at the mean point must be equal to total kinetic energy at the mean point. Class, are we okay with this? Are we okay? So what will be the total kinetic energy at the mean point? KE is equal to half m omega squared times A squared. Or you can express it as half m V maximum squared. But what is V maximum? V maximum is equal to omega times A. And this is a square. So when you square V maximum, you have omega squared times the square of the amplitude, which will bring you to the same equation here. So half times the mass is 100. So 0.1 kilogram times what's the angular velocity? You see, we are told that we know angular velocity to be 2 pi over t. And t is also total time divided by number of oscillations. Therefore, we can find t. T is equal to 15 over 20, which is 3 on 4. Okay, please help me determine 3 on 4 in decimal.
0.75
second. So once we have the period, we can easily calculate for angular velocity. Okay, but note that it is angular velocity squared. So omega squared must also be 2 pi over the period all squared. This will give us 4 times pi squared over the period squared. Therefore, omega squared would be equal to 4 times. Note that we're told that let's take pi squared to be 10. So 4 times 10 divided by 0.75 squared. Please calculate that for me. $40 divided by square of 0.75.
71.11.
71.11 radian squared per second squared. Come and then substitute that into the kinetic energy formula. So you have 71.11. The amplitude is 4. Change 4 to 4 centimeter to meter. And this is 0.04 squared. And you must get it. Okay. So it is not so difficult. It is not so difficult. Please, is there any question? Yeah, but give me your final answer. What is your final answer? What is your final answer? Oh, and Ebusianfo. And Co. The gentleman, I'm also listening to you.
Please, 0.1422.
Check your answer again. Half times 0.1 times 71.11 times 0.04 squared.
Mr. Edia,
Hello.
please, I had 5.68 times 10 exponents -3.
Or 0.005 what?
682.
Or 682. This is correct. So please double check your answers. When you are inputting this, take it gradually. Do not put everything together. Okay, 0.04 squared. Whatever you get, multiply that by 71.11. Multiply that by 0.1. Okay, then divide your answer by 2. Divide your answer by 2. And it must give you 0.0056, even 89. Please, Erefa, are you okay?
Yes, please.
So when we are inputting this, let's be very careful. Let's be very careful because it's easy, but if you are not careful, you can easily get it wrong. Another way to do this is to, I said the total energy, the mechanical energy at the mean point must also be equal to the total kinetic energy at the extreme. Total potential energy at the extreme. How do we calculate for potential energy? Potential energy at the extreme would also be equal to, yes, help me quote the potential energy formula. What's the potential energy formula? Omega squared times the amplitude. So m omega squared y. Okay, but at the extreme, y is equal to a. So m or I think there is half m, yes, omega squared times the square of the amplitude. There's a expression for the potential energy. Half, yes, Erefua.
Mr. Edia, please, I thought you said when we are using, like when we are considering an oscillatory body, we should use the MGH.
This is, you see, this is a loaded, a body of mass, so it's like a loaded spring. This is not a simple pendulum. I only use this to explain something to you, okay? I only use a simple pendulum to explain something. But this is a mass that is a mass of 100 grams that is oscillating. Are you okay?
Yes, please.
Okay, so half the mass is 0.1, then square of the amplitude, angular velocity. The angular velocity omega is, we've calculated for it. Okay, and that gave us 71.11 times the amplitude squared, 0.04 squared. So it will take, it's more or less the same thing as we have had here. So this must also give us the same value. Ladies and gentlemen, is there any question? If no question, let's quickly move on. And I like what Erefa is doing, probing, okay, stops, and that is good. Then the second question. Let me post the second question. A plane progressive wave. A plane progressive wave is represented by the equation y is equal to 0.4 sine. Please, have you seen the question?
Yes, please.
Can I flip to the next page? Class, can I flip to the next page? Okay, yes, once there's no. A plane progressive wave is represented by the equation y is equal to 0.4 sine 1000 per t minus 0.5 per x. Where y and x are both in centimeters and t in seconds. So where y and x are both in centimeters and t in seconds. The first question says that calculate the velocity of propagation of the wave. Calculate the velocity of propagation of the wave. Can you do that for me? Class, can you quickly do that for me? Calculate the velocity of propagation of the wave. So you have this progressive wave equation. You have to calculate the velocity and calculate the distance covered by the wave in 5 complete cycles. So you are answering I and II. Calculate the velocity of propagation of the wave and calculate the distance covered by the wave in 5 complete cycles. Make me proud. Hey, today's attendance is very bad though. Eh? I only have Bernard Baden, Bridget, Leslie, Elizabeth, Etonam, Evelyn, Osei Mensah, Rifwa, Fifi Pepra, Frida, Frederick, Glenn, Calvin, Leslie, Michelle, Michaela, Prince, Nathaniel, Rubin, Willis, and Isaac Atta. Come, let's solve questions. And you are not coming, so bad.
Our day. Today is our day.
Oh, but no matter what, we will end today. Eh? And the issue is that, you see, once you haven't tasted wasi, you are not done. I understand you. Sometimes fatigue comes in, but we are ending it. So calculate the velocity of propagation of the wave.
Recording in progress.
Okay, so let's solve it so that you can rest your brains today a little bit. So y is equal to 0.4 sine of 1000 per t minus 0.5 per x. When you compare this to y is equal to a sine omega t minus kx, we could conclude that omega is 1000 pi. Therefore, 2 pi f is 1000 pi. Pi will cancel out pi and 2 would go into 1500. So you have frequency to be equal to 500 hertz. And I want to determine frequency because I want to use f. V is equal to f lambda. Okay, so we equate k, wave number k, to 0.5 pi to find lambda. So we have 2 over lambda because pi will cancel out, giving us 0.5. Pi will cancel out from here. Therefore, lambda will be equal to 2 divided by 0.5. And class, what is 2 divided by 0.5?
Please, 4.
This is 4 centimeter. Therefore, our speed of the wave v will be equal to f times lambda, which is 500 times 4. And this would give us, what is 500 times 4?
2000.
2000 centimeter per second. Okay, or 20 meter per second. This is the speed. The second question demands that we find the wavelength for, calculate the distance covered by the wave in 5 complete cycles. For 5 complete cycles, 1 complete cycle is a wavelength. So we calculated for lambda and then got 4. Therefore, the distance covered by the wave for 5 complete cycles would be equal to 5 times, this will be equal to 5 times lambda, because the wavelength is the same throughout. And so this must give us 5 times 4, which is equal to 20 centimeter. That's all. Okay. And this particular question is also, I think, NOVDEC 2022. Then the last question. Sketch a displacement time graph for the wave for one complete cycle. Sketch a displacement time graph for the wave. Y is equal to 0.4 sine 1000 per t minus 0.5 per x for one cycle. Now, in plotting this, we must first determine the period. So if f is equal to 500 hertz, then the period would be equal to 1 over f, which is 1 divided by 500. And this will be 0.002 seconds. So in sketching this, because I'll use a period, so it's a displacement time graph. So the vertical axis and then the horizontal axis. This is why it's a displacement time graph, so I must label it accordingly. This is slash centimeter. Now, a complete oscillation is made up of 4 parts. So the period must be divided into 4 parts. Quarter of the period. So quarter of 0.002. Then half of the period. Half of 0.002. 3/4 of the period. And then the full period, which is 0.002. Note that we are doing this for one cycle. Okay. We have to show the amplitude because it will oscillate in between. The amplitude is 0.4. And then we also have negative 0.4. We are doing it for one cycle. That's why I only ended at the period. So when t is equal to 0, the displacement will be equal to 0. At time t is equal to 0, the displacement will be 0. When t is equal to this time, quarter of the period, and please here you can calculate and then put it there. Quarter of 0.002. Please calculate this for me. What's the quarter of 0.002? Nathaniel and Co, hurry up.
0.0005.
Again.
0.0005.
Okay, so we can clear this straight away and put it there. This is 0.0005. I just did this to show you because we've been using the equation. Now half of 0.002. What is half of 0.002? This would also
0.001.
So this is 0.001. 3/4 of 0.002.
Get 0.015.
So 0.0015. And then the period. Now when t is equal to 0.005, this will give us the displacement will be equal to the period 0.4. For the sake of understanding, let's do it so you can see. Y is equal to 0.4 times the sine of 1,000 per times a time, which is 0.0005. This part will go to 0 because there is no, we are not giving corresponding x. We are only plotting y against time. So this, the phase constant will go to 0. So multiply 1,000 by 0.0005, and this will give us 0.4 times sine of 1,000 times this 1, 2, 3. We have per times 0.5, and 0.5 is half. So this is basically 0.4 sine of per on 2. And per on 2 is 90. Sine 90 is 1. Okay, so the whole thing reduces to 0.4 times sine of 90. And since sine 90 is 1, this will give us a displacement equal to 0.4. This time at t is equal to 0.001, the displacement will be 0. You can confirm by using the equation. At displacement at time t is equal to 0.0015, the displacement will be equal to the negative of the maximum, the amplitude. You can put your values in to confirm. Then at a displacement, at a time t is equal to 0.005, the displacement will be 0. So when you join your points, you have this. They are true. And we have to do this for one cycle. So there we go. So it's not really difficult, but you must understand the concept and apply accordingly. Class, is there any question? Michelle, Nana Kwabena, Robin, and the rest of you. Elizabeth.
Stadium, can you go back like once so that I can see how we got the displacement?
Is it this?
Yes, please. Thank you.
All right. So it's just application of the same knowledge. Okay. All right. The next question. Let's answer this one. Refer, this is the question where you must apply you have a simple pendulum. You have a simple pendulum. The diagram below illustrates an oscillatory pendulum. This is a fixed point. This is Nigeria, one of the Nigeria physics questions in 2022. A Nigeria physics question in 2022. This fixed point is O. When it is at rest, we are told that the pendulum bob hangs here at A, and the length of the string is this is 60 centimeters. Then it is displaced through an angle 60. At B. Then the angle is 60. Then you are told that the vertical height between when it was stable, it's even taken from the center. So let me. To the new position. This vertical height, you are told, is 10 meters. 10 meters. Then it goes on to tell you that calculate the work done in raising the pendulum to point B if the mass of the bulb is 50 grams. Take G to be 10 meters per second squared. So we are told that the mass of the bulb is 10 grams. And we are to take G, 50. And take G to be 10 meters per second squared. Now, this distance of 10 meters is to, cause your downfall, because there is a way to determine H, which we did. But they're giving you this vertical distance of 10 meters is to be sure whether you, the student, can reason. Because we cannot have a pendulum bulb of length, a pendulum string of length 60 centimeters, and then when it is displaced by this angle, it will be raised by 10 meters. This is impossible. 10 meters is very huge. And look at the pendulum strength, just 60 centimeter, not even up to 1 meter. And then when displaced through this angle 60, and it will be raised by 10 meter. This is to be sure whether you, the student, can reason. Okay. The way out is what the theory. And so, are you there?
Yes, please.
Good. This is, we are to determine the work done. And the work done is the gravitational potential energy, which is equal to mgh. So we can find the work done as mg times the vertical height h. And that's a gravitational potential energy. What is the mass? The mass is 50 grams, which is 0.05. Gravity is 10. Then we need to find this vertical height h, because what they've given us is not realistic. So if once this is perpendicular to this side, if you take the cosine of 60, cos 60 is equal to this height from this point to this point over the hypotenuse, which is the length of the string L. So L, therefore, X is equal to L times cos of 60 degrees. Okay. The vertical height H is equal to the whole length of the string, which is 60 minus X. Therefore, H is equal to 60 centimeter minus L cos of 60. And L is also 60. So we have 60 out, 1 minus cos of 60. That will give us the vertical height H. H, therefore, is 60 centimeter times cos 60 is half, and 1 minus half is half. All right. Therefore, the work done is equal to the mass 0.5 times h times the vertical height, which is 30 centimeter. 30 centimeter change to meter would also be 0.3. So you put them together and you are good to go. Okay. So determine 0.5 times 10 times 0.3. Please calculate that for me.
1.5.
1.5 Joule. That's the work done. So this is a typical application of what you asked. Is that okay?
Yes, please.
All right. Please, if you have any question, you can ask so we can continue. Let me look for questions on different areas. Michelle, ask your question. Hello, Michelle. Michelle is
The
gone.
stadium. The next slide.
Just this.
Okay. This is fine.
I'm dropping a question soon. So just give me some time to edit it and then. Okay, I've just dropped a question. Au revoir.
Mr. Edia,
Mr. Au revoir.
please, the mass, why do we have 0.5 instead of 0.05?
I think the mass is 50 grams, isn't it?
Yes, please.
So when we divide by 1,000.
That's supposed to get 0.05.
Oh, I think I even used it here. So correct it for me, okay? Correct that. It's supposed to be 0.05. Thank you. Please correct it. 0.05. So that would also change our value. Leslie. Ruben and Co, you are not talking.
Yes, please.
And what will be the new value?
The 0.15 joules.
Yes, please.
Thank you. I've just sent a question. We have a wave. The diagram below represents a wave. The whole length of the wave is given. What is the speed of the wave if its frequency is 8.0 hertz? So do that for me whilst I upload other questions. So what's the speed of the wave if its frequency is 8.0 hertz? I've just forwarded another question. I've sent another question. And then another question. Okay, so the diagram below represents a wave. What is the speed of the wave if its frequency is 8.0 hertz? So if frequency of the wave is 8.0 hertz, what is the speed of the wave? Yes. Ruben, what's your answer? Share your answer with me. Ruben. Ruben, I'm listening. Hey, Nathaniel. Nathaniel.
Sir.
What's your answer?
Sir, please, I'm still on it.
Okay, Bilal, Ahmed. Bilal, it's been a while. It's been a while. You haven't been attending classes, true or false?
I only missed last week.
Okay. So have you been able to solve it?
So I'm working on it.
Who is true? Frida. Frida, have you been able to free it?
Yes, please.
What's your answer?
16 meters per second square.
16 meters per second. Oh, it's speed though. It's speed. So revise your unit. Meter per second.
Yes, please.
And then Calvin, have you been able to solve it? Isaac, the two Calvins. Isaac, what about you? Okay, then let's look at it. So yes, we'll need V. The speed is equal to F times the wavelength. F, we are told, is 8.0 hertz. What about the wavelength? So how do we determine the wavelength? This is what we have. One full wave. Let me draw my wave properly. So we have one full wave, another full wave, another full wave. And we are told that the whole length is 6.0. Okay, so we need the wavelength. So you count the number of complete waves you have here. You have 1, 2, 3. So the wavelength will be the length of the whole wave divided by the number of complete waves, 3. This is giving us 2 meters. Therefore, 8 times 2, and this is 16 meters per second. Okay, so that is how to go about this. And so Frida actually got it right. Okay, let's attempt this question. Once you have this trick, I think you should be able to apply it to this quickly. I mean this one, the question I've just highlighted. And we are to find the wavelength of this wave. What will be the wavelength of this wave? We have a wave whose full length is 5.0 meters. This question, I'll need one of the guys to answer. So guys, over to you.
So,
Hello.
yeah, the wavelength is 2 meters. I have 2 meters for the wavelength.
Okay, let's see. And we are told that the whole length is. So how do we determine the wavelength? Let's count the number of waves we have here. 1, 2, so it's 2.5. So 5 divided by 2.5 must actually give us 2 meters. Thank you. You got it spot on. Okay. Then this one too. So this particular question, we have the wave, it's a displacement time graph. And we have to also, what is the frequency of the wave? What is the frequency of the wave? Evelyn Osei, please, are you following? Evelyn.
Yes, please.
Okay, then Evelyn, this question is for you. You are to help us determine the frequency of the wave. Evelyn, are you ready? What is the frequency of the wave? Whose message? Oh, Evelyn, this question, the one I just highlighted on. I've just reposted it on the page. Let me see who is, somebody is getting 20. who has this chart? Evelyn, is that you? Bilal is getting 2 heads. I've really mixed out who sent the 20. It's an unknown name. What's your name? Whoever sent the 20 heads. Your name is not showing. Okay, it's been okay. Evelyn is getting 10 heads. Baden, Bernard, 10 heads. Let's see. Let's see who is who.
So I got 28.
Bernard got, okay, got 20 upon further consultation. Okay, so what is the frequency? Let's define frequency is number of complete cycles divided by time. So if we use this, we have 1, 2 cycles. And what's the total time? 0.10. So 2 complete cycles divided by a total time of 0.1. Let me see people's messages. Nathaniel, okay. Okay, Mami Adjoa, Mami Mate. So if F is equal to 2 over 0.1, we have 2 divided by 1 on 10. And this is 2 on 1 times 10, 20. If we look at it from this perspective. Another way of looking at the same question is that, what is period? The period is the time taken to make a complete cycle. Where do we have, or how, what is the shape of a complete cycle? A complete cycle from what we are given must be this shape. So what is the time? What is the time taken to make this shape? From the graph, the time is 0.05. So it means that the period is 0.05 seconds from the graph. Okay, so if F is equal to 1 over the period, then 1 divided by 0.05 must also give us 20 hertz. Please confirm this for me. But we have 1 divided by 5 on 100. So this is 1 on 5 times 100. 5 goes into 120. So the period is actually 20. The frequency is 20 hertz. Okay. All right. So please, those of you who got 10, make your corrections. Just effect the corrections. Okay, Bilal, okay. All right. Please let me give you 5 minutes break, okay? 5 minutes break, I'll get back to you. Mommy, your hand is up. Mommy, I'm listening.
So please, I wanted to ask how you got the frequency again.
Okay. So let's sketch the graph. What we have is this. The vertical, we have the horizontal, and so it's a graph of displacement against time. But this is Y. This is T. And we have 2 4 cycles starting from let me redraw it again. Okay. Mommy, if you could watch carefully, this time here from the graph is 0.05. Then the time here is 0.10. So I use 2 different ways to determine the frequency. One, because I know frequency is equal to number of complete cycles divided by total time. I try to count the number of complete cycles here. I have 1, 2, and the total time to this number of complete cycles is 0.1. So 2 divided by 0.10. Amiadwa, this I'm sure would give us 20 per second, isn't it? Amiadwa, are you there?
Yes, please.
So 20 per second, which is the same as 20 hertz. So this is one way. The other way is that knowing F to be 1 on the period. What is period? A period is the time taken to make one complete cycle. And from our graph, what shape constitutes a complete cycle? This shape. This shape. And what time is taken to make this shape? 0.05. So if I divide 1 by 0.05, it must also give me the frequency. And Mami Adwa, divide 1 by 0.05 and then give me your results.
Please, I got 20.
Good. So these are the 2 different ways I use to determine the frequency. Are you okay?
Yes, please. Thank you. Yes, please.
All right. Hello, your time is over. Your water break is over. Come and let's water the plant. I'm posting the next question. Okay, so look at the graph there. We have about 3 graphs. A, B, A, 4. We have 4. So base your answers to questions 13 and okay, you only have the question 13. Questions 13 and 14 on the diagram below, which represent waves A, B, C, and D traveling in the same medium. So we have 4 waves, A, B, C, and D, traveling in the same medium. Question 13, which 2 waves have the same wavelength? Which 2 waves have the same wavelength? Looking at waves A, B, C, and D, which 2 waves have the same wavelength? I'm also trying to look at it myself. I've seen it. So whoever is ready can quickly share what you have seen with us. Yes. Which 2 waves have the same wavelength? I'll look out for the question 14.
C.
Yes. Which 2 waves have the same wavelength? Anybody?
Please, I had C, B, and D.
You had B and D.
Yes, like C, yeah, option C.
B and D. So option C, we shall see.
Yes, sir.
More views. Which 2 waves have the same wavelength? Oh, more views. Yes, Frida.
Sir, please, I also
A
think
and
B
C.
and D.
Frida, is that yours? Is
A and C.
A and C?
Yes, please.
A and C. Nathaniel, you were also saying something.
B and D.
B and D. Okay, let me come in with what I have seen. Let me see, somebody has also sent a message. Refua, A and C. A and C, okay. So when I also look at the wave, A and C, it's actually A and C. A and C. Okay. So it's B. When you look at this, just look at the shape of a 4 wave. This shape. Whether it is so long or short, look at where these shapes are ending. If you look at A and C, they are all ending at the same point. Okay. The shape of a full wave, they are all ending at the same point. So they have the same wavelength. Don't forget, wavelength is measured horizontally. So if we are measuring it from their starting point, they will have the same length. Okay, so the next question, the question 14, says that which wave has the longest period? Which wave has the longest period? So look at it and then share it with me. Which wave has the longest period? Which of the waves, A, B, C, and D, has the longest period?
Please, I can't find question 14.
Oh, that's what I'm reading. It's not there. So put it down for me. Which wave has the longest period? Which wave has the longest period? Frida, hold on. Hang on. And what is period? The time taken to make a complete cycle. Which of the 4 waves has the longest period? Frida,
B.
Frida is going for B.
D.
And
D.
D, as in
Yes.
Daniel.
Yes, please.
And Eurefa is going for B.
Say A.
Who is going for A?
Nathaniel.
Nathaniel is going for A. Which wave has the longest period? Last opinion. Last view, then we move on. Elizabeth.
Please, I think B.
Okay, so final judgment. So when we look at the shape of a full wave, okay, the shape of a full wave for A, B, C, and D, the wave whose wavelength is longer must give us a longer period. And when we look at all of them, the wave B has a longer wavelength. And so its period will be longer. The wave with the shortest wavelength certainly is D. And so D would have a shorter period, time to describe that shape. Okay, so it is the wave B. It has a longer wavelength. And so the time taken to describe that lengthy distance, okay, will be longer. Please, is that okay?
Yes, please.
So that is how you analyze it. The time taken to make that distance or length will be longer if the wavelength is longer. And the time taken to make that shape will be shorter if the wavelength is equally shorter. So that is the problem of the day. All right. I'm going to give you a final question, which you would work it out. Then we discuss and we end the session. Good. Let me repost the question. Please, it's been done. So Nathaniel will go for our day anytime soon, okay? A point particle of mass 0.1 kilogram is executing SHM of amplitude 0.1 meter. So the mass is 0.1 kilogram. It's executing SHM of amplitude 0.1 meter. When the particle passes through the main point, its kinetic energy is 8 times 10 to the power negative 3. 8 times 10 to the power negative 3 joule. Obtain equation of motion of this particle if the initial phase of oscillation is 45 degrees. So obtain equation of oscillation of this particle if the initial phase of oscillation is 45 degrees. Ladies and gentlemen, this is the problem of the evening. Start work. So you are to write a displacement equation of this particle if the initial phase of oscillation is 45 degrees. So I'll come back to you in about 5 minutes time. Okay, let's discuss it. How do we have to write the displacement equation, okay? And we know a displacement equation of a particle, a vibrating particle with phase angle is given by y is equal to a sine omega t minus, usually a wave is seen to be traveling from left to right, the phase angle. So we'll need omega. The amplitude, we have it. The phase angle, we have it. So what is the value, or what do we, derive for omega? We are given maximum kinetic energy. You know, this kinetic energy is at the origin, so it's maximum. Maximum kinetic energy is equal to half m times V maximum squared. And V maximum squared is omega times the amplitude squared. Therefore, when we substitute that here, we have K maximum giving us half m times omega squared A squared. This is 0.008 is equal to half times the mass, which is 0.1, times omega squared, times the amplitude, which is also 0.1 squared. Okay. And so let's determine the value of omega squared. Omega will be 0.008 times 2. This times 2. So this is giving us 0.016 divided by 0.1 raised to the power 3. So this is 0.1 times 0.1. So you need to divide 2 by that. And what is 0.1 raised to the power 3? This is giving us 0.001. So 0.016 divided by 0.001. Okay. So when you input this, we have 16. Therefore, omega is equal to square root of 16, which is 4 radian per second. So once we have omega, we are good to go. Our wave, therefore, will be equal to 0.1 sine of (40) minus 45 degree S power on 4. That is the displacement equation. If you want to express it in terms of Don't forget, omega can also be 2 power f. So you can also go ahead, find a period and express it in, but omega is actually 4. Okay, so this is the easiest way to go about the problem. Please, au revoir.
Miss Adria, please, why are we leaving it in pi on 4 and not the 45?
You see, the reason is that, don't forget this whole angle, the 40 minus pi over 4 is phase angle theta. And in harmonic motions, the SI unit of the angular displacement is in radian. Okay, the SI unit of the angular displacement is in radian. This is the reason why I'm changing it from degree to radian. Are you okay?
Yes, please.
So whenever you have it, that is what you must do. You must quickly change it from degree to radian. The phase angle must be expressed as such. All right. Please, is there any other question? Is there any other question? If you don't have any question, then this is where we bring 2 months of online classes to an end. Ladies and gentlemen, go to school and then make us proud, okay? But you need to make time to go over. And whenever it is treated in class, you must be able to apply it so that whatever your parents actually paid for wouldn't be a waste. But you make your parents proud and also make Omega staffs proud. Just go to school and make us proud. We wish you all the best and a very safest of journey back to school. In fact, bye-bye.
Bye.